Hello, everyone. My name is Sida Shen. I am a product manager at PhoenixAI. We just rebranded from Data, but we still sell the same product, real-time analytical database, and we are still the maintainers of the StarRocks project, real-time analytical database, as hosted as a Linux Foundation project. And today, we're walking through the new features that's in StarRocks 4.1. So this is going to be a fun one. This is always like my favorite kind of webinar to do, where just talk about the features, the pain points. That's a lot of fun. Okay, so the whole thing should be 35 minutes, 40 minutes. So if you have a question, please ask them. I'll try to address all of them in the end. So now let's get started. So first, StarRocks and PhoenixAI. What are the differences? What are those, right? So first, StarRocks is an open source, real time MPP analytical database. PP means massive parallel processing. It's very scalable. You can scale joins, aggregations, all of those, every single operation horizontally. And it's really good at low latency, high concurrency like workload. It's the engine that powers PhoenixAI Cloud, which is the enterprise version of StarRocks. You can see that as a open core kind of model. The core is StarRocks, engine StarRocks provides the base performance. And PhoenixAI Cloud is a BYOC, enterprise grade cloud database, real-time cloud database. It's built around the StarRocks core. It follows the open core model, and it adds security, manageability, governance, and extra AI capabilities into it, right? And it's BYOC, so everything runs in your public cloud, like AWS, Azure, and GCP accounts. Um, Okay, so let's go over the agenda. So what we're gonna cover. So first, why 4.1 and some of the focuses with 4.1, the bigger story. And then we're gonna dive into what's new in StarRocks 4.1. Gonna be three sections. So storage, Apache Iceberg and Lakehouse. I should have put Lakehouse there. It's more than Apache Iceberg here. And SQL and query, right? And then we're gonna take a very brief look at PhoenixAI and how it takes 4.1, StarRocks 4.1 further, and some of the enterprise feature that's shipping with the PhoenixAI version of the StarRocks Enterprise StarRocks 4.1 core. Okay, and then we're gonna have time for Q&A. We're gonna answer all of the questions regardless of how long it takes, like always. So for recurring problems from production deployments, we've seen, at least me personally see even in the past 4 years, right? Build a database and move it to production and see a lot of challenges, right? So first is data distribution, right? It's storage. So partitioning, bucketing, all of the things are fixed, right? If your data change, your distribution change, it's suddenly skew happening, right? The only thing you can do before 4.1 is basically create a new table and re-ingest, right? And that's kind of expensive, for big tables. And now 4.1, we're looking to fix that. And second is schema change, right? Schema change, we had um, light fast schema change for share nothing. But for share data, it's still kind of a challenge. It's still not just a metadata operation. It's still kind of slow. And also, if you have Envy that didn't support that, it created a lot of pain. So, we had new features in this release to support that. And also Lakehouse, right? And we've been hyper focusing on serving queries on Lakehouse or open format tables, such as Apache Iceberg and Delta Lake, right? The read, we did so much optimization, but we haven't done a lot in terms of write, in terms of table maintenance. And you always needed some Spark job on the side to help you with that. And also, learning from our users, a lot of the Spark jobs are not really managed by the query engine or data warehouse team. So that creates a lot of like internal friction, right? A lot of slowdowns. And this release, we try to fix that. And also, slow queries. We are fast, but there are still instances that were slow, right? But observability into how the system is performing in terms of especially cache has always been a problem, right? Because PhoenixAI and StarRocks by default runs on object storage, whether it's an Iceberg table that sits in S3 or it's our internal table that does the real-time stuff, right? Everything runs on object storage, and cache is like everything. So observability into how cache is performing was not really that clear, right? And now in this version, we look to fix that too. Okay, so first storage. A data skew, data skew, data skew. We're a low latency, high concurrency database. A lot of our users use us as customer facing applications, right? So put the database server layer directly in front of customers. But for most of the customer facing use cases, it's always you have a big client that has like 50% of your entire data, right? And it creates huge data skew. Sometimes the biggest one is like 100 times as the median one, and in a distributed compute environment or distributed system, skew is always the biggest enemy, right? When it happens. And before, there were like two ways, you could model that, but none of them actually works. So let's say you have a big skew on tenant, right? You can do a bucketing on the tenant ID, right? And then you sort and you partition on the other columns that you're gonna use as where clauses, as predicates, right? And that is the normal way, right? But bucketing by tenant ID, you're gonna have like a bucket that's like it's too big, right? And then when it distributes, it's just a few nodes working on that one big account, and all of the other nodes like AFK and wait. And this creates a lot of um, um, wasted resources, and creates a lot of like tail latency for your bigger clients, which often to be like the more important clients. And or the second way, right? If you don't want that kind of uneven query latency, a lot of users what they do is, instead of like hashing or distributing by tenant ID, you distribute by another key, right? And you put the tenant ID as, let's say, like you sort by the tenant ID, right? But that's create even bigger problem, right? Because by not bucketing by the tenant ID, you're basically smooshing all of the like one tenant smooshing like across like all of the tablets, and reading, and every single read, despite how many tenants you include in the word clause. If it's just one, you have to the engine has to like read every single open and read every single tablet, and that is very expensive. Right, so nobody wants that. So in StarRocks 4.1, we aim to fix that by supporting range bucketing and automatic tablet and split merge. So what this does is that instead of distributing by hash, we still distribute by range. So what we can do now is you can distribute by range the tenant ID, right? And then we support automatic tablet split and merge. So let's say you have a big tenant here, right? It has a lot of data, but probably in the beginning it has not that much skew going on, right? It has like two tablets, but it grew exponentially. Um, uh, Compared to other clients, grew a lot more than the other clients. So it suddenly got more data, and StarRocks now 4.1 is able to automatically split those tablets into smaller ones, right? So this way you don't get the skew, right? But you also don't have to open every single tablet as you're just querying a few tenants, right? And this is off by default, so you have to turn it on by yourself, right? And also this is a pure metadata operation. The tablet split and merge. So you never have to like re-ingest the entire table again when your data distribution change. This is probably the biggest feature in StarRocks 4.1. And also, what if there are some use cases that you have a skewed um, field that you cannot use a range partition on, like date? Like, what do you do, right? And we have another fix for that. So now we support large capacity tablets. The reason for that is that if you have a big tenant and you have small tenants and all of them follow the same tablet or bucketing rules, right? You would have a lot of tablets for the big ones, And the small ones to follow the same rule, right? It has to have the same amount of tablets, but it probably has like 3 rows of data, right? So you end up having a lot of small tablets, uh, which is very bad because every single tablet has a fixed cost, right? So opening them, although it's kind of cheap, but it's not free, right? So opening each tablet is not free, and also it's more in terms of shuffling, right? When you do like a when the storage does when the query execution does a shuffling, right? It shuffles more tablets to other nodes, and that creates a lot of cost as well, right? And also each tablet creates a little overhead in the metadata, so FE end up having more pressure, memory pressure, and CPU pressure if you have too many tablets that are too small, right? Too many that you don't need, right? So now we support tablets to a size that is up to 100 gigabytes, right? Per tablet. So it's much more efficient in a lot of use cases, especially in Skew, with the data Skew, when you cannot really do a range bucketing. And to make those big tablet works, there are more works underneath that was done, right? So write, now it's parallel. So CPU and IO, you can so basically writes a tablet, the CPU writes like half, and it starts already like shipping that into the storage, right? And compaction now is parallel. So determining how depends on how big the tablet is. StarRocks is able to decompose that into several subtasks and do them like parallelly, right? To cater to those like 100 gigabyte tablets, and also primary key index, right? So before, if you have new data that come in, right? Indexes were not built until it's used, right? It's always built on demand, and now it's a backend job that does it as early as possible. So even the tablet is big, not going to create too much of a problem, right? So this is how we made a big tablet actually work in StarRocks 4.1. And also we have a customer already, a pilot customer that cannot share the name, unfortunately, but they have a very mutation heavy real-time booking platform, right? Ingestion latency now is very stable at sub 5 seconds. They have really, really big scale and a lot of data scale. Okay, next is fast schema evolution V2. So before fast schema evolution, only metadata operation only works in shared data. Now it works only works in shared nothing tables, shared nothing clusters, and now it works with shared data. And the new implementation is a pure 100% pure metadata operation. It doesn't even depend on like how many partition or actually how many tablets you have, right? It doesn't need to go through every single one of them, and it's a lot faster. And it's actually like this is actually a copy pasted from my local StarRocks instance, 0.00 seconds. It's a very fast change. And also it works on synchronous materialized views. Now, if you have a synchronous materialized view, you can still do this with fast schema evolution. Okay, and next is cache observability. Both StarRocks and PhoenixAI rely on cache very, very heavily for 2 reasons. First is because everything's shared data, like I just mentioned, right? So all of the data that you use with StarRocks or PhoenixAI is persisted in S3, right? Or in an external object storage that's S3 compatible, right? And second is that the kind of use case that people actually normally use us, a lot of them are like customer facing that requires very low but steady query performance, query latency, right? And before, one of the problem is, when cache fail, the IO is obviously becoming the biggest bottleneck when the query latency is like milliseconds, right? And we want better observability into how cache is performing. Now we have a lot of new entries inside of our audit log and also our SQL profile. So when you see a slow query, you know where to look at, and it's better, for troubleshooting those performance issues, right? Okay, so this is cache observability. And also we have other features that were introduced in shared data storage. So first is inverted index. Inverted index is for text search, right? And we supported inverted index with share nothing. I think 3 point. God, I don't remember. It's 3 point. I think 3.4. 10. One of our users contributed that. And now it's more optimized in share nothing, and it is now available in share data tables, right? So you can do full text search and also have share data architecture, right? And also we have more statistics and more metrics in terms of how the tablets are performing, right? With automatic split merge, the tablet's size and what's inside, it's gonna change a lot, right? If you want to see like what the tablets are doing, and now you have statistics, you can query them, that you can know like when it's emerging or when is it splitting, right? And we'll also ship a bunch of other features, like automatic cluster snapshots for backup and restore, a dry run for table repair, fast cancel for ingestion job, a lot of smaller optimizations that you are able to see in our release note on StarRocks.io slash doc.starrocks.io slash release notes. I think that's the link. Go Google it. And okay, so that was storage. Next is Lakehouse and Apache Iceberg. So one thing that we've always been good at was fast Lakehouse, fast Apache Iceberg query survey, right? We did so many optimizations. We brought our expertise from data warehousing, from like those customer facing analytics kind of use cases we've been running forever, right? And porting a lot of the statistics over, right? Porting a lot of the late materialization, all of the other optimization over, and we have dedicated a lot of specialized optimization just for Apache Iceberg tables, such as we're able to parallel process even the manifest files, for example, right? For your petabytes big Apache Iceberg tables, or for your metadata, if it's like too many small files, we have ways to solve that. But one thing that we've been lacking a little bit is the table maintenance side. It's the ingestion and update, right? Because that also still requires a Spark cluster on the side to do those jobs, because we don't support them. And also a lot of those jobs, the owner of that is not the same people that owns the PhoenixAI or StarRocks cluster, and that creates a lot of problems, right? And in 4.1, we really look to solve that problem, right? So write and delete and truncate. Let's go through each one of them. So now we support delete on Iceberg tables, right? So basically, now we support writing standard V2, Iceberg V2 delete, position delete files, right? The one that with the slow write, but the fast read, right? The position delete files. So we support native deletes on Iceberg tables, right? So if you want to delete some rows, you don't have to start another Spark job or ask someone to do it for you, right? And next, we support truncate tables on external Hive and Iceberg tables, right? So that again, you don't have to use a Spark cluster. And also, we supported commit queue to avoid concurrency commit conflicts. So this is a more of an Iceberg mechanism problem. So Iceberg follows a optimistic concurrency control. So you have different commits that come in, right? And Iceberg will always assume they will be successful, right? It doesn't check. So and it rejects, later one when there's a conflict, right? And now we can queue the commits instead of just firing random ones. So we decrease the number of jobs that are commits that are being conflicted or being rejected from Iceberg. So ultimately speed up the performance. And also we supported global shuffle by partition transform, right? For syncs. So this solved the problem of small files. So when you have multiple writers and writing to multiple partitions, the number of files you generate is the same as the two numbers multiply with each other, right? So you end up with a lot of small files, and that's the worst case, right? And now we are able to write, sync, um, shuffle by partition, and sort locally, right? So you have end up with much less small files. So there's less compaction to do afterward, and also immediate reads are much faster without compaction, right? That makes sense. Okay, so that's Iceberg. Write, delete, update, truncate, and read and write optimizations. Okay, and now the next one is Iceberg V3. Now we support variant data type. And this is a great data type because if it doesn't have that, you have JSON. JSON is very flexible, right? But the engine needs to parse it, and then execute, and that's actually not really vectorized. Um, or you have some kind of columnar format, right? Into a columnar, but you want to add a field. It's not really that flexible, right? And variant gives us a great uh, combination of the both, right? Gives us a binary that's both flexible, and we can compute them vectorized in a vectorized fashion, right? Distributed across all of the CNs, and which within each compute nodes, we can parallel process that with multiple threads, right? In mini batches, and now we support reading those semi-structured data files, a data format variant in Apache Iceberg. And then it's a bigger feature on Apache Iceberg, and this is also a longer term project that we've been working on, and we are working on still in the future, and also in the future. It's incremental materialized view. This is an extension into our asynchronous materialized view with StarRocks. So the problem with asynchronous materialized views is it's very useful, right? It's by partition refresh. It can automatically rewrite your query so that you don't have to like change your SQL, just point to the raw table and it rewrites for you, right? But the bigger problem is the partition level refresh. If you have partition, it's not even that fast, right? It's a full partition is still a lot of data, but a lot of the tables it doesn't even have like a partition key you can use, right? And that creates a lot of problem. And now we support incremental materialized view on Apache Iceberg. And this is basically based on Apache Iceberg snapshots, right? So for each commit into Apache Iceberg table, um, um, it creates a new snapshot, right? And we just follow that and compute the delta, and then we can work, right? So now instead of recompute the entire history or the entire history of that partition, now we're able to only compute the incremental delta, right, with your Apache Iceberg writes or updates. Oh no updates, just writes because it's append only, which is support. And yeah, and now you can run queries fast with like real time or 5-minute kind of real time sync into Iceberg. Okay, so this is incremental materialized view. You can read about it in the docs as well. And next, Iceberg V3 and other new Lakehouse open table format releases. So first is Iceberg V3. Now we support variant, and we support default values. We can read row lineage, right? And also we added procedure for read write manifest, right? And we optimized expired snapshots and remove orphan files, right? And those are the standard maintenance you would do on your Iceberg tables that you can do directly with StarRocks now, today, right? And file path and row position metadata columns from Iceberg tables, right? And all of the others, right? And for catalog and Pymon, other table formats, we also have a lot of other supports. If you're on something that's not Apache Iceberg, don't worry, we're still working on those, right? Just to show you guys. If you want to read the details, we have blogs on the starrocks.io/blog. page, and also we have the documentation release note. Please take a look there if any of those apply to you. Okay, and next is a SQL and query. So first is a big one, a recursive CTE, right? So this creates a lot of problem because if you don't support recursive operation and doing it outside of the database in the application layer, there's a lot of workaround you have to do. And also performance is probably a concern, if that's not written optimally, right? And now we support recursive CTE, so you can take off this recursive kind of semantics directly with SQL, right? So first, let's just example, right? So you have employee ID and the manager of that employee, like this is the same ID, right? So 42, 42 is a hundreds boss, and 100 is 200's boss, right? Go on from there, right? Instead of it's like a tree structure, right? So this is like the CEO, and this is the next layer, next layer, next layer, the port 200 intern. And now you're able to write a recursive operation, right? So with this query, basically, from ID 42, right? You want to see like what's under like 42, right? Everybody under 42, and each layer is gonna peel and return data, right? And go down another layer and return until there's no data that returns, right? So end up you with something like this, right? With 42 and each level, each depth below, the report you report to the manager. So what is the other way? How do you call it? It's employees, let's just say 42's employees, right? Yeah, so recursive CTE. So now you can write a recursive operation with just SQL in StarRocks 4.1. Okay, so next is Skew join and window function upgrades, right? Skew join, this is a big problem because you join on a key. If you join on a key that's skewed, right? And that's the same problem with the other skew problem we talk about, right? You will have nodes that are working very hard, the nodes that are AFK and just waiting, right? Because it doesn't get that much data because the key skew. And now we're able to automatically detect skewed join keys from the statistics, right? From the histograms statistics, and the skew keys would become like its own separate plan, maybe like a broadcast join, right? And the rest of the data that's not as skewed can do a shuffle like normal, right? So this takes care of a lot of the resource waste that comes with joining on a key that has skews. And then window functions, right? A lot of optimizations, right? Let's just talk about the first two. Count distincts over windows, and now we can write multiple count distincts over windows. So you don't have to like say write a subquery first and get the data and then do the window function. A lot of resource waste, right? And then skew partition keys, right? If you do a window function, a group by on the key that's skewed, same thing, right? Now we're able to use statistics to identify them and split them and unit them automatically together, right? So that's other smaller performance optimizations that you probably might not use, but you're gonna feel in production or when this skew happening. And also we supported a bunch of new functions. We haven't given up on any of the data types, right? JSON, array, string, and time. It's a lot more than this. Take a look at the release note. And now we have AI functions. So you can use AI query to call an external AI model, directly using SQL with no code, right? Okay, so, and now we support full outer join using syntax. And that's really cool. And some of the upgrade nodes, so start at 4.1.1, not 4.1.0, because 4.1.0 has a pretty nasty bug, right? 4.1.1 has a fix. And also, if you're on 4.1, the tablet layout is very different from before. So if you're on 4.1, you can only downgrade down to 4.0.6 plus. And some of the new defaults you have to know, right? Some of the parameters are on by default now. So take a look at the full detail at docs.starrocks.io release note release 4.1. Take a look at there, right? And this is all the features I wanted to highlight for StarRocks 4.1 release. And now just take a little look at PhoenixAI and what it is, right? PhoenixAI is the enterprise layer on top of the StarRocks core. StarRocks is basically at the core of PhoenixAI is the engine, the storage, right? And it follows a BYOC model. So basically, what it means is that we have a control plane, right? That's our in our VPC, and you have your enterprise StarRocks cluster with enterprise features that still sits in your cloud account, right? And we are able to do maintenance, upgrades, everything on your cluster remotely from our control plane, right? And also no data flow through PhoenixAI. And also you have the option to encrypt every single thing. So we don't have any access to your data. So maximum security and ownership of your cluster as well as your data, right? So bring your own cloud and bring your own data lake. We don't manage data lakes as well. So we do want you guys to have ownership of everything, right? StarRocks and PhoenixAI, just quickly go through some of the differences. StarRocks is open source and PhoenixAI Cloud is a fully managed BYOC experience in your own cloud account. And workload isolation. StarRocks has resource groups, which is basically like soft resource isolation, right? But that's not the whole picture, right? You need soft resource isolation for some of the workloads, so you don't waste resources, but you also need multi-warehouse. So ideally, you would want resource group inside of warehouses for it to actually works, and that's supported in PhoenixAI. And more security features, governance features such as cell level access control policy, transparent data encryption, right, and OAuth, and Kerberos, and others, instead of just plain RBAC in StarRocks. And availability, right, and StarRocks has cluster snapshots if you want to do your backup restore or like your failover. You have to implement a bunch of things yourself, and some of them are not actually like even doable. And PhoenixAI Cloud gives you multi-AZ, even a multi-AZ availability, and even cross-region backup recovery, right? That's in the minutes. Bring back the cluster. And also more caching options, right? So make sure that your query performance is even more stable than your StarRocks counterpart, right? So cache replication. So even your nodes goes down, we have another copy of the cache we can go to, right? And warm up across all of the replicas, right? So you don't hit that first kind of slow query, right? And tooling and support, of course, you get 24/7 support from the original StarRocks team or the StarRocks maintainers. Okay, and here are some of the new features that shipped with PhoenixAI StarRocks core. So some of the new ones. So first is cross-region disaster recovery, right? So basically that's a periodic snapshot backup, right? So we can recover the entire cluster automatically without you actually doing anything within minutes, just with that snapshot information, right? And more rich cache statistics, right? Say cache versus total bytes per tablet, cache ratio, and all of the other good statistics that we have, just for PhoenixAI, and also per warehouse resource group, right? It's supported in 4.1 StarRocks Enterprise Core with PhoenixAI. Now you can configure your resource group within each one of the warehouse, so you have more um, specific or sophisticated control over your resources. So not like just have a warehouse for one user, right? That's a lot of resource waste, right? So this really decrease your resource waste with multi warehouse. Okay, so that's everything I have. Is there any questions? Okay, so there are some questions. I'm gonna go through them one by one. First question: loading a Parquet file into StarRocks fails with no value in no non-nullable column, but I verify Parquet file contain no null for that column. What kind of table is that? That's weird. So put in the ticket on put in the issue on our GitHub page. Somebody will take a look. Make sure to include like as much information as you can. It's very difficult to hold on that. And also we do have a troubleshoot AI with our Slack channel. So if you're not in our Slack channel, please join. Okay, and another question is, wait, let me go to Q&A. Are you planning to support Iceberg table optimization, such as compacting manifests and data files without relying on external tools like Spark? Yes, that's exactly what we're doing. And now we support grooming your manifest files, and also with 4.0, um, we supported compacting data files. But still, I mean, the approach we take with Spark is a little different, right? So you still need, like, for your big jobs, you still probably want to use Spark for that. But for example, like our compaction, our data file compaction, the way we do it is like a temporary fix, right? So for example, if you run into like a slow query, and the problem is with the data file being like too many of them, right? You want to like fix that on demand. We're able to like use all of our CPUs and factorize the whole thing. So yeah, uh, yeah. So for now, probably Spark is still kind of, you need that for like some of the bigger jobs, but we hope to eliminate that in the future. Do any of the features of 4.1 still applicable to share nothing cluster? Uh, a lot of them is share data catching up to share nothing. I think a lot of them are cache, which is not applicable for share nothing. But I don't see any features that's supported here and not in share nothing. Yeah, all of them are in share nothing or share nothing already have. Yeah, this is the same behavior across share nothing and share data. How does AI query work with a table? Can you give an example? I don't really have an example right now, but I'm happy to draft something up and publish that later. Uh, yeah, I'll actually do that. Yeah, stay tuned. Is commercial support available for StarRocks? For StarRocks, not really. But we do have Phoenix Anywhere, which is a better version of StarRocks. Uh, more features that you can deploy anywhere. You can basically on-prem Phoenix AI or on-prem commercial StarRocks. So the short answer, I would think, is yes. Do you have any plans to support store procedure? Oh my god. Uh, uh, Not really. We focus a different use case, but we do have multi-statement transaction that you sort of you can hack that into that. Any plans to open source the multi-warehouse features? I don't think in the short term that's a lot of work to do. Stay tuned. We're probably gonna have more updates in the future. Okay, so that's all I have. Wait, let me go back to the last page. That's a lot of pages. Okay, so thank you so much, guys, for coming. Check out the release note. 4.1.1. If you want to use 4.1, use the 0.1.1.1.1 version. And definitely check out PhoenixAI Cloud, cloud.phoenixdata.ai. We have a cloud product. We have a on-prem anywhere product with Kubernetes. So if you're interested, please let me know. And also, we're running a 30-day free trial on the cloud right now today. So please go get it. Okay, so that's everything I have. Thank you guys for showing up. Really, thank you so much. And we're gonna restart our webinar series from now. So I'll try to do like 2 a month. And be sure to tune in for the next one. Now all of the rebrands are over. Finally, we can get back on the webinar train. So thank you so much, guys, for showing up. See you guys again next time. Thank you. Thanks so much.